सालना बनाओ का ना कहाँ तुम्हारा माँ कुकर नहीं पूछना
Aisha, I'm here. Aisha, come here. जल्दी आओ.
सब धुल लिया.
Hello everyone. Today we are going to do the live based on maths question papers, 2 marks questions. Today we are going to solve. Give some time to the other friends to join. Please wait. Let us start the first problem. In an arithmetic progression, if A20 is equal to 820 and A20 equals 79, then find its first term. Given we have S20 is equal to 820, A20 is equal to 79, we have N is equal to 20. To solve this problem, we need to use the formula Sn is equal to n by 2 in bracket a plus an. Yes, 20 is equal to, in place of n we have to substitute 20 by 2 into a plus a20. So we know that by cancelling 20 by 2 we get 10. Now we have S20 is equal to 10 into A plus. Now you can substitute the value of A20. So A20 is 79. So S20 is equal to, we can substitute the value, that is 820. That equals, you can multiply the value inside the bracket, 10 into A plus 10 into 79. So 10 into 79 is 790. Now shift the, we have LHS equals RHS, so you can write 10A plus 790 in the left side and write R in the RHS 820. So LHS equals RHS. So no need to changing any sign, as we have LHS equals RHS. Now shift 790 to the right side, we get 10A equals 820. Now 790 plus will become minus, so minus 790. So 10A is equal to 820 minus 790. So 820 minus 790 is 30. Now cross multiply. So A equals 30 divided by 10. So 10 ones are 10 threes are. So A is equal to 3. So this is the required value what we need to find. They have asked us to find out the first term. So now we have found out the first term, that is A is equal to 3. Kindly revise the problem. Now moving on to the next problem. So we have how many numbers between 201 and 401 are divisible by 6. So first we need to calculate the numbers which are divisible by 6 within the series 201 and 401. So first of all we need to calculate the numbers which are divisible by 6. So first number which is divisible by 6 in 201, we need to calculate the numbers between 201 and 401 are which are divisible by 6. We have, so starts with 204. So if you add to 6 it will get 210. Next you get 216 and keeps on adding. The last term we get within 401 will be 396. So first we have to write the given values. So the given values we have A is equal to, first term you have to write 204. Next you have to write the nth term, that is An equals 396. Now we need to find the common difference. We know that it is found out by A2 minus A1. So D is equal to A2 is 210 minus A1 is 204. So minus 204. So we get D is equal to 6. Now we have to write the formula. So here we need to find the number of terms. So n is equal to question mark. Now we have to use the formula An equals, for nth term, An equals A plus n minus 1 into D. So An we have 396, that is equal to, first term is 204 plus n we need to find n minus 1 into D we have 6. Now shift 204 to the left side, plus will become minus. So 396 minus 204. So that is equal to 6 into n minus 1. 396 minus 204, you have to subtract the value. Subtracting we get 6 minus 4 is 2. 9 will remain as it is. 3 minus 2 is 1. So 19, LHS first you have to write 6 into n minus 1, that is equal to 192. Now cross multiply 6. We get n minus 1 equals 192 divided by 6. 6 ones are 6 threes are 1 carry, 6 twos are 12. So n minus 1 equals 32. Now shift minus 1 to the right side. So we will get n minus 1, n equals 32. If you shift minus 1 to the right side, it will become plus. So n is equal to 33. So the number of terms we have found out is n equals 33. kindly revise the problem. Now we need to go for the next problem. Solve the given pair of linear equations using a suitable method. Here no method is mentioned. You can use any type of method required to solve this problem. You can use elimination method or substitution method. So we will be using elimination method. So here we will be using the elimination method. So for the elimination method, you have to add or subtract the given equations to get the required result. So writing the both equations, we'll observe and choose whether you have to add or subtract. So now we can see we can add, as plus y and minus y are there. If you add plus y and minus y gets cancelled, you will get the result. So by adding plus y minus y gets cancelled, 3 plus 2 is 5, 5x is equal to 8 plus 7 will be 15. Now cross multiply 5, you will get x equals 15 by 5, 5 ones are 5 3s are 15. So x is equal to 3. Now what you have to do, you have to take any one of the equation and substitute the value. So we'll take 2x plus y equals 8, substitute the value of x as 3, 2 into 3 plus y is equal to 8. So multiplying the value, 2 3s are 6 plus y is equal to 8. Now shift 6 to the right side. We have y is equal to 8 minus 6 plus 6 will become minus. So we have y is equal to 8 minus 6 is 2. So y is equal to 2. So x is equal to 3 and y is equal to 2. We have solved the given equations to get the required variables. Kindly revise the problem. Now we are going on to solve the next problem. So it is based on the quadratic equations. Find the discriminant of the quadratic equation and determine the nature of the roots. So 2x square plus 3x minus 7. So in the quadratic equation, we have to work find the determinant of the quadratic equation and determine the nature of its root. So the given equation is 2x square plus 3x minus 7 equal to 0. Here we need to find the discriminant of the given equation. After getting the discriminant value, we have to check whether it is greater than 0 or less than 0 or equal to 0, and finally decide its nature. So the given equation is 2x square plus 3x minus 7 equals 0. Minus 7 equal to 0. First of all, you have to compare the given equation with the standard form of quadratic equation. So the standard form is ax square plus bx plus c equal to 0. So we have to compare to get the required value. So a equals to b is equal to minus 3. So we have to check out in the equation they have given 2x square plus 3x minus 7. So it's not minus 3x, it is plus 3x. Therefore b equals plus 3 and c equals to minus 7. Now we have to now we have to write the discriminant equation. So discriminant equation is given by delta equals b square minus 4ac. So delta is equal to, substituting the values, so b we can see it is 3 minus 4 into a we have 2 and c is minus 7. So delta is equal to 3 square is 9. So minus into minus we get plus. 4 2s are 8, 7 8 are 56. So therefore delta is equal to 56 plus 9, which is 65. And we can see 65 is greater than 0. 65 is greater than 0. Therefore it is clear that we can write the nature of the roots, which is roots are real and distinct. As 65 is greater than 0, roots are real and also they are distinct. So this is the final answer what we calculated. Now kindly revise the problem. I need going to find the different values, express the quadratic equation in the standard form. So we can see the new question. Express the quadratic equation in the standard form. 2x plus 3 into x is equal to x square plus 1. So here you have to multiply the given values, add, subtract, and get into the standard form. So the standard form is ax square plus bx plus c equals 0. So first we'll write the given equation. 2x plus 3 into x is equal to x square plus 1. Now multiply the given equation with x. So x into 2x we get 2x square. 3 into x is 3x is equal to x square plus 1. Now shift the values to the left side. We get 2x square plus 3x. So plus x square will become minus x if you shift to the left side. Minus x square plus 1 will become minus 1, that is equal to 0. So 2x square minus x square we have 1x square plus 3x will remain as it is minus 1, that is equal to 0. So now you have to write the standard form of the equation. So the given standard form is ax square plus bx plus c is equal to 0. We can see we have written the given equation in the standard form. That is the required answer for the above question. Kindly revise the problem. Now we are going for the new question. So the new question is based on real numbers. So for the new question which is based on real numbers, So we need to prove that the given value is an irrational number. So then next question is prove that square root of 5 is an irrational number. So here we have to prove that root 5 is an irrational number. To do this, first we have to make certain assumptions. After making certain assumptions, we have to make that our assumptions are wrong. So by proving that our assumptions are wrong, we will prove that the given value square root 5 is an irrational number. So first we have to start making the assumption. Let's start making an assumption that let root 5 is a rational number. So I'm writing here we have to prove that root 5 is a irrational number. Let root 5 be a rational number. First we have to make the assumption now root 5 is equal to a by b, where a and b are co-prime numbers and also b is not equal to 0. B is not equal to 0. Now you have to square on both the sides to get the required values. So squaring on both the sides we get root 5 whole square is equal to a square by b square. So square and square root gets cancelled. 5 is equal to a square by b square. Now cross multiply b square. So we get 5b square is equal to a square. So this makes clear that, let this be first equation 1, and this makes clear that 5 can divide a square and also a. 5 can divide a square and a. Now we have to make some assumption. Let a is equal to 5k. Let a is equal to 5k, where k is an integer. Where k is an integer. Now substituting the value of a in the given equation, we'll get the required function. So we have to substitute the value of a by 5k in equation 1. So we have 5b square is equal to 5k whole square. So 5b square, writing, we get 5 square is 25. So we can write 5 square only. K square by 5. 5 gets cancelled in the numerator and denominator. So b square equals 5k square. So now it is clear that 5 can divide. So k square is cross multiply 5, we get b square by 5. So it is very easy and clear that 5 can divide both b square and b. Five divides b square and b. Therefore, it is clear that both a and b have 5 as the common factor. 5 as the common factor. but this contradicts that A and B are co-prime numbers, but this contradicts that A and B are co-prime numbers. A and B are co-prime numbers. Hence, our assumption is wrong. Therefore, root 5 is an irrational number. So this is the thing we need to prove. So we have proved. Kindly revise the problem. Now we are going for the next problem. So in the next problem, we are going to find the coordinates of the point which divides the line segment joining the points 1 comma 6 and 4 comma 3 in the ratio 1:2 internally. So this is the coordinate geometry problem. So in this problem we need to find the point which divides the line segment in the given ratio. So for that given line we need to use the section formula, and it is divided internally, and the ratio has also been given. Find the coordinates of the point which divides the line segment joining the points 1 comma 6 and 4 comma 3 in the ratio 1:2 internally. So first of all, we'll draw a line and write the coordinates, and need to find the divided ratio coordinates. So at one point we have 1 comma 6, and at the other point we have 4 comma 3. So these are the points which have been divided 1 comma 6, 4 comma 3. So the divided point is in the ratio 1:2. So let this be the unknown point x comma y. Those be the coordinates x comma y. So let the unknown point, we need to find out x comma y. Let the given coordinates are x1 y1 and x2 y2. Now we need to find the write the ratio. So the given ratio is m1 is to m2. So that is 1:2. So we can understand and observe easily that the formula to be used to calculate the points or the coordinate of the points which are divided is by using the section formula. So the section formula is given by, let us consider the point be P So the section formula is given by P of x is equal to, so P of x comma y is equal to m1 into x2 plus m2 into x1 divided by m1 plus m2. This is the first coordinate. For the second coordinate, we have m1 into y2 plus m2 into y1 divided by m1 plus m2. Close the bracket. P of x comma y is equal to, we have m1 is 1 and x2 is 4. We have m2 is 2, x1 is 1 divided by m1 we have 1 plus 2, m1 we have 1, y2 is 3, m2 is 2 and y1 is 6 divided by 1 plus 2. Close the bracket. P of x comma y is equal to 4 ones are 4 plus 2 ones are 2 divided by 1 plus 2 is 3. Similarly, 3 ones are 3 plus 6 twos are 12 divided by 1 plus 2 is 3. Close the bracket. P of x comma y is equal to 4 plus 2 is equal to 6 by 3 comma 3 plus 12 is 15 by 3. Now you have to divide by 3. 3 ones are 3 twos are 6. 3 ones are 3 fives are 15. So the point coordinates P of x comma y is equal to 2 comma 5. So this is a very important problem. These problems have been used many a times in the exams. So kindly revise the problem, understand the concept. In the coordinate geometry, always you need to understand the concept in terms of figure. Then it is easy for you to write down the required formula and you have to do the basic calculations to find out the final answer. Kindly revise the problem. We are going for the new problem. So this problem is based on trigonometry. In the given figure, find the value of tan p and cos r. In the figure, find the value of tan p and cos r. So by seeing the problem in the diagram, we have PQR 12 centimeter, 13 centimeter and 5 centimeter of all the three sides of the triangle. So it is very interesting one. So first we need to find tan p question mark and cos r question mark. So first of all is tan p. By definition of tan p we have opposite by adjacent. So here p is the angle. So you have to consider theta at p. So we have to consider the angle theta at p. So if the angle is at p, then opposite to that angle we find opposite side and adjacent to that 90 degree. So here we need to write 90 degree. It is a right angle triangle. So adjacent to 90 degree, that will be the adjacent side, and the other side we know it is the hypotenuse. So by using that angle theta we'll find the answer. The opposite is 5 and adjacent is 12. So tan p equals 5 by 12. Now we need to find cos r. By definition of cos theta we know that adjacent by hypotenuse. But here we have to observe, we have to take the angle theta at r. So you have to consider angle at r. So that is theta. So now opposite to that angle will be the opposite side. So now PQ will become opposite. Now adjacent to 90 degree, this will become adjacent. So here QR will become adjacent. So the third side hypotenuse will be as it is. So now we have consider angle at R. So this is a very important form. You have to consider angle at R. So therefore we have cos R is equal to adjacent is 5 and hypotenuse is 13. Therefore cos R is equal to 5 by 13. So this is the final answer for cos R and tan P. Kindly revise the problem. Now we are going to solve the problem based on circles. In the given figure, CP and CQ are tangents to the circle with center O. ARB is another tangent at R. Show that the perimeter of the triangle CAB is twice the length of tangent CP. So this is a very important problem. In the figure, CP and CQ are tangents to the circle with center O. ERB is another tangent at R. Show that the perimeter of the triangle CAB is twice the length of tangent CP. So the diagram is already given in the question. So we can see we have a circle. So first of all we need to find the perimeter of the triangle. So the triangle is CAB. So the perimeter of the triangle CAB we need to find. The perimeter of the triangle CAB is equal to AB plus BC and CA. The perimeter of the triangle CAB is equal to CA plus AB plus BC. Let this be equation 1. From the figure we have CA is equal to CP minus AP. CA is equal to CP minus AP. Similarly, AB is equal to AR plus BR, and BC is equal to CQ minus BQ. So BC is equal to CQ minus BQ. Now substituting the above values in equation 1, we have substituting the above values in equation 1, we have perimeter of triangle CAB is equal to CA minus AP, AR plus BR plus CQ minus BQ. CQ minus BQ. Let this be equation 2. Let this be equation 2. So from theorem 10.2, we are going to substitute the values. From theorem 10.2, we have the length of the tangents drawn, from the external point, the lengths of the tangents drawn from the external point to a circle are equal. The lengths of the tangents drawn from an external point to a circle are equal. To a circle are equal. So using this theorem, we need to substitute the given values. Therefore, we have CP is equal to CQ, CP is equal to CQ, AR equals AP, and BQ is equal to BR. BQ equals BR. Therefore, we have CP equals CQ, AR equals AP, and BQ equals BR, and BQ equals BR. Now the given equation 2 becomes Now given equation 2 becomes perimeter of triangle CAB equals CP minus AP plus AP plus BQ plus CP minus BQ plus CP minus BQ. So here we can see you can cancel the same values with opposite sign. We can cancel same values with opposite sign. So plus AP and minus AP gets cancelled. Similarly, plus BQ and minus BQ gets cancelled. So we have CP plus CP. 1 CP plus 1 CP is 2 CP. So this is the required answer. The perimeter of triangle CAB is twice the length of tangent CP. So therefore we have proved the given condition, that is perimeter of triangle CAB is equal to twice the tangent CP. Very important problem we have solved using the theorem 10.2 and many more conditions. So they have given this in for 2 marks. So it's a very important one. Kindly revise the problem to understand it better.
ज्यादा खाना क्यों सामान नहीं खा
Now we're going to the next problem. So the product of HCF and LCM of two numbers is 216. If one of the numbers is 42, find the number and also find the HCF of the two numbers by prime factorization method. The product of HCF and LCM of two numbers is 216. If one of the numbers is 42, find the other number. Also, we need to find the HCF of the two numbers by the prime factorization method. So first we need to write the given values. So from the question it is seen that they have given the product of two numbers, that is 260. Product of HCF and LCM is 216 and one of the number is 42. So the product of HCF and LCM is 216 and one of the number is 42. Let the first number be A is equal to 42 and let the second number be B. Let the second number be B, which is we need to find, and also they are given the product of HCF and LCM of the numbers is 216. HCF into LCM is 216. We know that product of two numbers A into B is equal to product of two numbers A into B is equal to A into B is equal to product of LCF, HCF and LCM. HCF and LCM. So therefore we have A cross B is equal to HCF into LCM. So here we know the value 42 into 5 equals 42 into B equals HCF into LCM we have 216. Now cross multiply by 42. We have B equals 216 by 42. Now choose any number which is divisible on both the sides. So I am using say 7 to divide on both the sides. So the divisible number 7 on both the sides. So in the denominator it cancels by 6. 7 6 are 42. In the numerator it first to take the two number. 7 2s are 14. 6 carries you have 61. You have 7 8s are 56. So 7 8s are 56. So 61 minus 56 is 5 carry. So we get 56. Again 7 8s are 56. So we get 288 by 6. So now we can cancel 288 by 6. 6 ones are 6 fours are 24. 4 carry. 6 8s are 48. So B is equal to 48. The second number, if we have found out, which is 48. So the other number B is 48. Now we need to calculate the HCF of these two numbers by the method of prime factorization. Calculate the HCF by the method of prime factorization. So first we need a one number and keep on dividing that number with the, so 2 twos are first, 2 twos are 4, 2 ones are 2. So we have to use prime numbers only. So 7 threes are 21. Now we have to divide 3, which is another prime number. 3 ones are 3. So we have to divide until we will get 1 as the number. So 42. The prime factors are 2 into 7 into 3. Now the second number is 48. Now we need to divide 48 by the prime numbers. So the first prime number which is divisible is 2. 2 twos are 4. 2 fours are 8. Now again divide by 2. 2 ones are 2. 2 twos are 4. 2 6 are 12. Now again by 2. 2 threes are 6. Now the last number, prime number is 3. 3 ones are 3. So 48 we have got the factors. 2 4 times, 2 into 2 into 2 into 2 into 3 only one time. Now you have to compare and get the HCF. So first number 42, 2 into 7 into 3. Second number 48, 2 into 2 into 2 into 2 into 3. So now you have to check the common numbers, common factors on both the numbers. So we have 2 as common, then we have 3 as common. So 2 and 3 are the HCF, the multiple of the numbers 42 and 48. So HCF of 48, 42 comma 48 is equal to 2 into 3. You have to multiply these factors. Therefore, the HCF of 42 and 48 is 6. So this is the final answer. We need to find the HCF of the given numbers by prime factorization method. So this is the method we need to follow. Kindly revise the problem. It is a very important one.
आपको ये निकला शुरू का
So we now completed the all the 2 marks question in the question paper 1 model question paper of the SLC students. We have completed. We have some of the important problems asked by our students. So let us solve some of the important problems which are very much required for the exams. Let us start some of the important problems. So we have find two consecutive odd numbers whose product is 99. So this is the first problem. Find two consecutive odd numbers whose product is consecutive odd numbers whose product is 99, whose product is 99. Let the first number be x, so it must be the odd number. So there are two odd numbers which are consecutive. So there are two odd numbers which are consecutive, means they are one after the other. Let the first number be x. Let the second number be x plus 2. So for odd numbers or even numbers, the gap is 2. So you need to write x plus 2. So consecutive one after the other. So please understand it is one after the other and their product. So x into x plus 2 is equal to 99. So it gives the proper meaning. So x into x is x square plus x into 2 is 2x equals 99. So if you shift 99 to the left side, plus will become minus. So minus x square plus 2x minus 99 equal to 0. So now you have a number 1 into 99. So you have 99. 1 into first number and last number must be multiplied. So 1 into 99 is 99. So let us find the two factors of 99. So if you add or subtract, you should get the middle term. So the factors to get 99. So the first number is 11. So again the second number is 9. So we can see both are odd numbers. 11 and 9 are odd numbers. So 11 nines are 99. So also their addition and subtraction, you should get the middle term, that is 2x. So 11 you have to subtract. So 11 minus 9, first you have to multiply 11 into minus 9, that is plus into minus minus. 11 nines are 99. Now you have to add and subtract 11 minus 9, that is plus 2, that is the middle term. So that is the middle term. Therefore x square plus 11x minus 9x minus 99 equal to 0. Now group the factors, first two and the last two terms. The common value is x plus 11. So similarly you have to write here x plus 11. Now you have to work out for the factors. We can see both are different, so minus. Now if you use 9, you get the required value. 9 into x is 9x. 9 11s are 99. So now your common value is x plus 7 on both the sides. Shift x plus 11 to the outside, you get x plus 11. The remaining value is x minus the remaining value is 9 equal to 0. So you have to equate the factors to 0. X plus 11 equal to 0 and x minus 9 equal to 0. So shifting 11 to the right side, you will get minus 11. Shifting minus 9 to the right side, you will get plus 9. So as the value is negative, so it is not be considered. So you have a positive value, so x equals plus 9. So therefore the first odd number is x equals 9, and the next consecutive odd number is x plus 2, that is equal to 9 plus 2, that is equal to 11. So 9 and 11 are the odd numbers which are consecutive, whose product gives 99.
सोच आप सार कुछ ना कया नहीं है, चुप साथ में मेरे उठो बैठो खा कर आज सो जा।
Kindly revise the problem. It is a very important problem asked by the students. It comes under quadratic equations. Kindly revise the problem. Very important one. Now we are going for the next problem. The next problem is based on arithmetic progression. The 24th term of an AP is twice the 24th term of an AP is twice its is twice its 10th term is twice its 10th term. Its 10th term. Show that 72nd term is 4 times the 15th term. 72nd term is 4 times the 15th term. So the 24th of term of an FE is twice its 10th term. So we have to write the given value. We have A24 is equal to 2 times the 10th term. So A24 is equal to A24 is equal to 2 times the 10th term. 2 into A10. To show that A72 is equal to 4 times A15. We have A24 is equal to 2 into A10. A24 can be written as A plus 23D is equal to 2 into A10 can be written as A plus 9D. A plus 23D is equal to 2 into A is 2A plus 9 2s are 18D. So LHS is equal to RHS. 2A plus 18D is equal to A plus 23D. Now shift the values to the LHS. 2A plus A will become minus A. 23D, 18 will be in the right side, it will become minus 18D. 2A minus A is A. 23 minus 18 is 5D. So we have A is equal to 5D. Now for the 72nd term we need to calculate A72 is equal to A plus 71D A72 equals A, we have 5D substituting. A72 equals 71 plus 5 is 76D. 76D. So now consider 4 into now consider 4 into A15 is equal to 4 into A15 is A plus 14D. Now cross multiply 4 into A. A we have to write A is 5D plus 14D. So 4 into 5 plus 14 is 19D. Now if you multiply by 4 into 19, 19 fours are, we get 76D. Therefore, let this mark it as equation 1. So A72, from equation 1 we have A72 equals 4 into A15 equals 76D. So A72 is equal to 4 into A15. So 76D in place of A72 we can see from equation 1, and we will need A72 is equal to 4 into A15. So therefore we have solved the given equation, which is given as A72 equals 4 into A15. So kindly revise the problem and make sure you have understood well. Thank you for joining us. We'll make more and more classes which will be helpful for the students. Kindly join us in our future live sessions, and also do subscribe our channel and kindly share the link of our videos with your friends. Thank you.